Okay, a couple things I want to address right off the bat before we dive completely into this.
Wait, what was the correct answer?
I'm going to get into that. Just hold on. Okay. Tonight, Ford ACE brake system principles due. Okay, so please make sure that you are going through that lesson if you have not already done so, going into Google Classroom and completing that form before midnight tonight. Okay. That's going to be the first assignment that's going to go in the grade book for fourth quarter outside of the lab. Let me go ahead and just review how we do this, okay? So you go to highschool.fordservicetraining.com. You sign in. Here's the website, okay? From here, what you'll end up doing is you can go over here to the book where it says Learning Paths, right? And if I'm searching up this particular lesson, Brake System Principles, right? Search there, boom, first thing that pops up, okay? Click on that, then you can hit launch. Once you do launch, it'll give you a little pop-up, right? And then, just barely. Let's see here. It's probably going to look like this when you first start.
Upon completion of this lesson, you will be able to identify the purpose of...
Anyways, again, it reads it to you. But you can go through this, navigate it. Obviously, headphones would probably be nice just due to the fact that if you're in a crowded study hall or something, let's say, you want to hear it. Otherwise, there is a CC up here where it gives you the captions so you can read it. This is also cool because it gives you some pretty cool animations, and it'll show you some stuff and information that I can't show you because of just how my presentation is set up. Okay, so this is again to further the information that's being given to you in class, to again help review that information, help you learn that information, and kind of start putting these pieces together. So then that way you can actually learn how brake systems work on cars. All right. Anyways, at the end of this lesson.
Wait, what is this? I want to watch this.
Okay, at the end of this lesson, there's a quiz, you could take it, but again, what you're going to end up doing is going into Google Classroom, going under classwork, going all the way down to certifications, and you'll see here brake system principles. If you go ahead and open up that instruction, there's a link here to a Google form, right? Like this, and then you just got to fill that information out. That's your quiz. Submit this form, that assignment is completed.
How many people are done?
Well, according to Google Classroom, at this moment, 5 of you are done.
Who's all done?
Well, that's for me to know and for you to know or find out if you turned it in or not. By the way, if you don't know if you turned it in or not, you can easily go back in to Google Classroom and click on the link and find out. I think you can only submit one quiz. So if it opens up and says you've already previously submitted it, you're done. Also, can we put the backpack on the ground, please?
We also shut the flag.
It's up to Giovanni if he wants to. Otherwise, he might get a suntan. All right, let's hop into this. My goal today is to get done with this presentation so that way when we get back to school on Monday, we are going to be able to hop into disc brake systems and then hopefully finish that in 1 week. So again, I'm going to be going a little faster today, so make sure that your notes, right, are not super neat. They're going to be messy on purpose. Okay, we left off here yesterday when fluid pressure is applied to a brake caliper. The piston moves the pads against the rotors. So again, everything is derived from my brake pedal. I press on that brake pedal, pushes on the push rod, goes through a brake booster, goes into the master cylinder. That master cylinder has a piston in it, which is then pushing on one end of the circuit for the hydraulic system. Okay, that pressure that I'm pushing on that liquid is then transmitted through the brake line, undiminished, to my caliper. Okay, and then that's where we're going to start generating friction. I said we were going to answer questions here in regards to your plickers. So one of the options was a metering or hold-off valve. So that is a basic automotive component you're going to find. Proportional balance valve, that is also basic component. What was the other options? I forget. Let me hold on a second.
hydraulic valve.
Brake booster, we talked about that. Let's go back in here. Brake booster. Where's my brake booster? Vacuum booster. Okay, that's a basic component, which means option C, a hydraulic return valve is not a basic automotive brake assembly part or component.
What is that for? Did you just make that up?
I just made it up.
Good job.
Yeah, sounds legit, doesn't it?
No.
Doesn't sound legit?
No.
Well, then I didn't fool you, which is good. Anyways, these are all components and parts that we talked about yesterday. So hopefully you had that information in your notes. If you didn't, I would probably include that information at some point in time in the future because that'll be important to know for the upcoming test and obviously the lab. Okay.
When is our test?
When we get through the information. I don't have a date set as of right now. All right, anyways, getting into here. We've got a piston. Okay, again, this piston is not like a cylinder engine piston where we're burning fuel to drive power through our crankshaft into our drive shaft. But this piston is going to be able to push out and retract based off of the force of the brake fluid pushing on it. Okay? And obviously this piston, as it's being pushed out, is going to be pushed against a brake pad that has friction material on it. And then that pad is going to come in contact with our rotor. Again, these are all stuff and components that we'll be talking about here today and in the future. And that is what generates the heat in order to slow down the spinning of the rotor, which is obviously bolted on through our lug studs here into the wheel. Okay, so that's how we can slow down and stop a tire from spinning. Now the fun part is I do not just have one brake pad. Okay? I'm going to have two brake pads, one on either side of that rotor. So we're essentially sandwiching that rotor between two brake materials. Okay, it's much more efficient that way. We only have one piston though on this particular configuration, which is kind of interesting, right? So how in the world do we move this particular brake pad against the rotor when we're pushing out on the other side? Okay?
It gets pulled in.
Yeah, how? Why? That's always the fun part, right? All right, disc brake pads have a steel backing and a lining made out of heat-resistant friction material. Okay, that's components. Again, we'll get more into this probably next week when we get into our disc brake system. But just understand that we have a steel backing, kind of hard to see on this particular piece. Okay, steel backing on this. I don't know, it's on the back side of this. And then we have actual brake pad material right here. That's what's going to be making contact with the rotor. Okay. This backing, or not the backing material, the lining that's heat-resistant friction material can be made out of a bunch of different types of material. Okay. The more popular type right now is it's made out of ceramic. It has ceramic material built into it. That's just simply because ceramic is able to resist heat very well and not wear out super easily. Back in the day, we used asbestos. Okay.
Not good.
No, it's horrible because this stuff turns into brake dust, right? And if you breathe that in, it is known to cause cancer.
Oh.
So it's not very healthy. So we've transitioned from asbestos over to like semi-metallic or ceramic brake pads. However, a word of caution, we always assume that the brake pad material is made out of asbestos. So as we are preparing to work on the brakes, we want to make sure that none of this brake dust becomes airborne and we breathe it in. That would be very, very detrimental to our health. Okay, so there are some procedures here that you're going to want to make sure that you're following as we are performing this lab.
So we would die.
Okay?
Are any of the cars out there that have asbestos?
No. Okay, but I'm going to teach you how to maintain or do the service so that way we can mitigate that issue.
Are we wearing like a mask?
We're not wearing masks.
Are we wearing a gas mask?
No. Trust me, just hold on to your horse, I'll show you. It's not overly complicated.
My horse is in here.
But the fun part about this is I'll show you how to do it, and then everyone's going to be like, do we really have to do that? When you're here, yeah, but when you do it out in real life, no, you can do whatever you want. And then all of a sudden, 40 years from now, when you got cancer, don't write me a letter and say, hey, Mr. Geske, I wish I would have done what you told me to do.
Yeah, I'm not writing you a letter.
Okay? No, probably not. I'll be dead by that point in time. All right, the brake disc. Something you want to write down. Brake disc. When you go to search information up on Identifix, this is what you're going to be searching for, brake disc. You know it better as a rotor though. Okay? The rotor, also known as a brake disc. Typically made out of cast iron and steel. Okay, the reason why we make it out of cast iron and steel is because it's going to get hot. We need it to be durable and actually be able to resist such high temperatures as we are braking. Okay? Now, depending on where our disc brake is located at, whether it's the front brakes or the rear brakes, is going to determine if it is a vented or a solid rotor. Okay? The picture that you see here, that green rotor, that is a vented rotor, which means air can get actually in between there. Why would we want air in between our rotor?
Cool it down.
To help cool it down. Because again, we're going to be creating friction. We're going to be creating heat. Right, Emerson? We don't want it to become super saturated with heat rapidly. So, because our front brakes are doing 60 to 70% of our braking force, we are going to have vented rotors in the front to help cool that stuff down quicker.
How do you get them to glow orange?
Press hard on the brake pedal for a long period of time.
Or you just don't spend it.
Okay. Now, one of the things that we have to keep in mind in Wisconsin is that over a prolonged period of time, these rotors, because they're made out of steel and iron,
Rust.
and it's going to have a bunch of salt and water on the road, what's going to happen to them?
They're gonna rust.
Yeah, they're going to rust, not on the surface where the brake pad is contacting out, because that's going to help clean it up. But in between here in the vented areas, that can rust. And as rust forms, it expands, right? Which basically creates a blanket on the inside of our rotor, and that blanket is going to prevent heat from being able to escape. So we're actually going to hold it in for longer. So this is something that we have to keep in mind when we're doing our brake service, because hey, our rotor looks like it's in fantastic condition. Did you check what the vent on the rotor looks like? Does it look like it has an accumulation of a lot of rust? If that's the case, it might be better for the overall health and longevity of the braking system to just replace that rotor. Okay?
Aren't rotors kind of expensive?
They used to be. They used to be. Generally speaking, now you can find them pretty reasonable. Okay.
So that's pretty reasonable.
I've seen them as cheap as $25 a rotor. Now again, that depends on what type of vehicle you have, right? Because if I have a big F-250, those are going to be a lot more expensive because it has much more mass and obviously much more braking force, so they're going to have to be beefier. Okay, which means there's a cost to that. Okay, but if I have a Honda Civic, new rotors, probably not super expensive. Okay. Anyways, vented rotors have fins for air to flow through. Again, this helps prevent brake fade. What's brake fade? It's where the rotors or the braking system is saturated with heat and we can no longer apply friction to generate heat because we're at our maximum, so we can't slow down or stop. Okay? So these vents allow for that cooling to happen more rapidly, which means we have a less likelihood of reaching that saturation point, which means we have a more likelihood of being able to use our brakes for longer and harder. Okay? Our rear brakes, because they're only doing 30 to 40% of our braking force, typically are not vented. Okay? Those are just a solid rotor. Okay? They're not going to necessarily heat up as quickly or as hot, and they don't need such active cooling as our fronts. Okay? All right, calipers. And some master cylinders are going to have a bleeder screw attached to them. Again, part of our maintenance on our braking system is not just checking on the rotor and the brake pads and those materials, but also going to end up being changing out that brake fluid frequently. Okay? So how do we get rid of all the old brake fluid that's in our brake line? we crack open this bleeder screw, and then we can press on the brake pedal. We have just artificially created a leak in our hydraulic system. When I push on that brake pedal, all that force is going to cause that fluid to come out of that bleeder screw. Okay? So there's a process here to where you can open and close that bleeder valve so you don't introduce air into the system, because that would be bad, but allows you to flush out or bleed the old brake fluid from the system as you are introducing new fluid in through the master cylinder. And then that incorporates through the entire brake line. Okay, it's not a very challenging task to do. There are tools that allow you to do this with one person very easily. We're not going to get into that right now, because again, it's not a task that we're going to ask you to do. But it is something that's fairly simple, quote unquote, to do. Okay. As you can see here in this illustration on the right hand side, this technician has got a flare nut wrench on the bleeder screw. They've got an actual straw or a hose hooked up to that, leading down here into an old used water bottle. Okay. Crack it open, push on the brake pedal, old fluid comes out. It's not dripping everywhere, not creating a mess. It's going into a container. Okay, as soon as that fluid stops flowing out, they close it, they let off the brake pedal if there's a person inside of it, right? They push on the brake pedal again, they open it up, brake fluid comes out. And every once in a while you still add new brake fluid to the master cylinder. Okay? And again, once you get done, once you have fresh brake fluid that's clear coming out of your hose, shut it off, you're done, go to the next spot in the brake system. Okay? And again, there's a sequence to where you want to do that based off of if it is diagonally or longitudinally split
I
system.
can find that out. Is there a thing that's adding too much fluid?
Is there a thing that's adding too much brake fluid?
Yeah.
Yeah. Technically speaking, there is a min and a max level on that. On the master cylinder, you don't want to max that out. And the reason for that is because, as you're going to see later on when we do our brake service, we have to take that piston that's in our caliper and we're going to push it back in. That's going to force the brake fluid to go back into the master cylinder, and that can overflow and or damage our ABS components. So yes, we want to not do that. Anyways, if we suspect that we also have air in our brake system, okay, we want to make sure we get rid of that air, because again, we want nothing but solid hydraulic fluid, brake fluid, or liquid in our brake line. So if I have air in my system, the way to get rid of it is through this process. Crack it open, hit the brake pedal, air bubbles should come out. You keep doing that until no more air bubbles come out. Okay? So again, there is a technique there. Here's an actual picture of that process happening. My caliper's right here. Obviously my brake disc. Here's the bleeder valve. I got a straw coming up down here, and I've got brake fluid already in there with the straw going all the way down to the bottom.
Are we gonna do that?
No. We could. It's not a very difficult lab to do. It just takes time. We just don't have time for it.
We're not gonna legal?
No.
What are we doing?
You can learn bleeding.
You're going to change out brake pads and rotors and
Oh.
do all that sort of stuff.
Oh.
Okay. All right, parking brake system. Our normal brake system that's going to be used with the brake pedal is a hydraulic system, right? It uses liquid to transmit force undiminished throughout the circuits to the various different calipers. Our parking brake system is not a part of our hydraulic system. Okay, our our parking brake system is mechanically linked to the rear tires in most cases with a cable. Okay. Your parking brake is 99% of the time used in order to lock the wheels in place from rotating when you are parked. Hence why it's called a parking brake. Okay? So if I'm parking on a hill and I don't want my car to roll backwards or forwards depending on which direction I'm facing, okay? Put it in park, lift up on or engage the parking brake. That basically grabs a hold of those rotors, or if it's in case of like a drum style, pushes the shoes out against the inside of that, prevents the wheels from rolling, and it's actually very difficult to get the car rolling because again, physics says an object at rest wants to stay at rest, so it doesn't really take a whole lot of energy in order to do that. So these are not very strong brakes, they're just there to help prevent the wheels from moving as you are parked, okay? There is a whole process through this because if we are working on our rear brakes, we have to take into consideration our parking brake cables, and that might mean a readjustment of those cables, so that way when I lift up on my handbrake or push down on the brake pedal, parking brake pedal with my foot, depending on which configuration I have, those parking brakes adjust accordingly, okay?
So what's the safety behind that if you pull it while you're driving?
Just goes out. It's fine.
What's the safety behind it?
Yeah, cause mine won't let me do it.
Then it needs to be readjusted.
Really?
Yeah,
It works when I park at my grandma and grandpa's,
sure.
but like,
If you're not supposed to engage it while you're driving,
well, it was snowing out.
okay?
And it didn't work.
Yeah, they're not the same as your normal brakes. It's not meant to generate a ton of friction to stop you doing whatever.
I wanted to slide,
I understand that.
and it didn't block my back wheels up.
Correct.
It was kinda to that.
That's because it's not designed for that. Alright, some vehicles we're actually starting to see a electronic motor take the place of our physical cable connection on our parking brakes, okay? So instead of having a handbrake or something with a cable going back to the rear wheels, we literally have a button on somewhere on the console on the dash where we can hit that button, and we have an electric motor that's basically then pushing out on that brake pad or the shoes. Most likely it's going to be a disc system to lock those in place, okay? So it's nice because now all of a sudden I don't have to adjust any cables. Okay, that's all going to be self-adjusted through the electronic motor and sensors. But it's our electronic parking brake. All right, Volkswagen is really into this stuff right now, but we're starting to see that on more modern day cars.
And with the
Okay.
electric parking brake.
Electronic parking brake.
Gotcha.
All right, parking brake system is mechanically or electronically operated by cables and levers, as we stated previously. If let's go through this incredibly rare scenario.
Ooh.
Okay, I got my hydraulic systems. I've got two circuits in that, diagonally or longitudinally. I've got a leak in one of my systems. Okay, that means I still have at least 2 tires in my hydraulic system that'll be able to slow me down. But let's hypothetically say I have leaks or damage in both of my circuits. I hit the brake pedal, I can't slow down or stop. I've lost all my hydraulic ability to stop. Okay? In that rare circumstance, like 0.001% of that chance happening, how do I slow down and stop?
Your parking brake.
Your parking brake also can sometimes be called your emergency brake or your e-brake. Okay? In that case, you could engage your parking brake. Understand though that your parking brake is linked up with only your rear tires. So again, you're only going to have maybe 30 to 40% of your braking force available. It's not going to be stopping anytime soon, but it will eventually slow you down and stop you safely as you are decelerating. Okay, at that point in time, you 100% need to get the vehicle towed and get that repaired. Okay, there's only one time in my entire career driving that I've ever had to actually engage my e-brake in order to slow down and stop.
Was it scary?
Okay, it was surprising. I wasn't scared because I knew what to do. Right, but what ended up happening was way back when I was in high school, I had a vehicle that I did not maintain very well, and one day I pressed on the brakes and the brake disc basically fell in half because it was so thin. Okay, at that point in time the pads were pressing on it, but it wasn't stopping anything.
So did your foot go all the way to the floor with the
Oh,
brake?
100%. All right,
Imagine.
and I was in traffic too.
Oh, shit.
I was in traffic, and we were going. So at that point in time, 4 ways on, handbrake up, allowed me to slow down. But I was a little bit more arrogant at the point in time. I just drove home that way, which was not a smart thing to do.
That would be scary. Imagine you're just driving and like you're going to stop at the red light and you just like push your brake and it doesn't do anything, you push farther and you just keep going
Yep.
all the way to the floor.
Yep. But here's the fun part, right? You have to be prepared for that scenario as a driver at any point in time. What do I do if this happens?
Yeah, I don't
Right?
think like that.
I understand that. Most people don't. But the
What
problem
I
is
do right now is
the problem is if you start panicking, guess what you're gonna do?
crash, die. I did that.
Right? You freeze up. And if you freeze up, you're getting an accident because you're not doing anything. You have to train yourself, and I know this is difficult to do, you gotta train yourself to not panic. To always be thinking, okay, calm down, stay calm, figure out the problem, and go with it. Okay?
What if you do?
I understand not everyone has that capability. But you gotta be placing yourself in that mind. Hey, if someone jumps out on the road right now, I mean, what am I doing?
Hitting over?
Most people aren't thinking about that scenario when they're driving because they're just doing this. They're daydreaming about TikTok, Instagram. Oh,
No,
what am I
I
gonna do later? They're not focusing on driving.
I just watched TikTok instead.
They're allowing the car to drive, which by the way is very dangerous and another advocate for why we should not have steering wheels in the cars, because then the car can watch out for you and actually do things. Levi, you had a question.
Yeah, newer vehicles that have like electric, like levers. How's that gonna work?
What
In an emergency.
they have electronic braking or
Like,
Yes.
it's like a little switch instead of.
They don't let you.
oh, for parking brakes?
Yeah,
You
yeah.
can still
No.
You can still flip up on the switch and stuff, see? Yep. Yep.
Not my dash card.
Yep.
While you're driving?
While you're driving. Yep.
You know, what's so
Yep.
Mm-mm.
Okay, go ahead and try it. By law, it's gonna have to happen. Now, the fun part is we're actually starting to see, those sensors through ADAS. Again, I'm not gonna get into what that is, but, radar, LiDAR, cameras on the cars, to where even if you're not paying attention, the vehicle is able to actually engage a separate hydraulic system through your ABS system
It's kinda
in
weird.
order to slow down or stop the vehicle, even without your driver input. Okay, those systems are already in existence.
And like the
Okay.
cruise things.
Yep, adaptive cruise control.
I hate if
Yep.
there's a street.
Oh, I hate it so much. Yeah, you hate it until it prevents an
Yeah.
accident, and then you love it.
There's a street where you can go, like, you can keep going straight or you can turn. And if you're turning, and there's a car coming going straight.
Yep.
Slams on the brakes and it's like, bro, they're not even close to me.
Exactly. So the technology is not perfected yet, but it's a whole heck of a lot better than we had 20 years ago.
Well,
20 years ago we didn't have that.
20 years ago, you
Which,
got-
to be fair, I'll just go on a little bit of a soapbox here for a second. 20 years from now, the skill level it will be required in order to drive a vehicle will be very, very low, to the point where you could have a 10-year-old hop in a car and drive the car, which is not, I don't think, very intelligent.
How do you
Back when I was 16 years old, you had to do everything on the car, driving manual, stick shift, paying attention, parallel parking. You developed the skill, right? So at this point in time, I'm very
The old
skilled when
people
I'm
still
driving.
can't drive.
Okay? Nowadays, kids, you guys don't have to do half of that stuff. It's literally put drive and just go, and you're expected to just be able to comply with everything else. It's kind of weird.
So what do you mean by like 10-year-olds will be able to drive?
Because again, we're going towards no steering wheel.
So you're just gonna get in and say, take me to Mr. Getsky's house.
Yep.
Just gonna-
Like here's a scenario I envision, right? I own a car, it's in my driveway. My kids, let's say, 5 miles away at their friend's house, 10 years old, right? I will be able to pull my phone up and go to this address. My car automatically drives out of my driveway, goes to that friend's house, my kid hops in, right?
Return home.
They'll say, hey dad, can you take me home now? I'll go, sure. Hit a button on my phone, and then the car drives back home and drops my kid off. That's gonna be a thing.
No
And then
way.
there's gonna be the smart people who don't have cars.
Yeah, no, it'll almost be to the point where your insurance company is gonna say, either you have this, or you're paying like $3,000 a month in insurance. You go, I can't afford that. I'm gonna get it.
How much are these little cars gonna be?
I don't know. At this, if we're gonna go really think way out ahead of things, you're not even gonna own cars in the future.
So what's gonna happen to Ford and GM?
They're gonna go through a subscription model. They'll make cars, right? But instead of owning it, you'll pay a monthly subscription, and then what ends up happening is you don't have vehicles in the driveway. You say, oh, I gotta go to work. You have a set schedule. Car at 7 o'clock in the morning comes, picks you up in your driveway, and then just automatically drives you to your work because the GPS already has the address in there. Drops you off, and then drives and picks up another person. It's just gonna be a taxi. robotaxi system.
But you can buy these cars that they're yours.
Eventually, we're gonna get to that point, but then beyond that, you're not even gonna wanna own it. You just pay a monthly subscription.
Are people already trying to make self-driving cars?
Yeah, Tesla's doing
Have you
so.
ever driven a Tesla?
Anyways, we're running behind on things. Anti-lock braking system, ABS.
But you don't have to be.
How does my ABS system know when to actually engage itself? Well, we have something called a wheel speed sensor. Okay? Wheel speed sensor is a sensor that is literally monitoring the RPM of each tire rotation.
Rotation?
Okay? If it notices that one tire is rotating slower, right, or not at all, it's assuming that the brakes are locking up that tire and it's not rotating properly. It will then send that signal to the computer. The computer says, wait a second, this tire is slipping when it shouldn't be. It is then going to independently press the brake for that particular corner or release the brake for that particular corner in rapid succession. Sorry, that's a very difficult word for me to say.
Succession.
Right? To the point where it allows the tire to keep rolling, but to slow down. Okay, that's how anti-lock brake system works. Okay, because if you were to literally press on the brake and hold it there without ABS, there is enough friction that you can generate in that braking system that will be greater than the traction of the tire to the road. So you will just lock it up, the tire won't rotate, and it will literally skid on the road. Right? Gives you nice black marks on the road. You're burning rubber. But the problem with that is, as soon as you lock up that tire, you've lost all traction and you've lost all control of the vehicle, which means you're going for a ride. You can't turn, and you're not stopping.
You just have to let off the brake.
Well, here's the fun part, right? Ideally, the perfect scenario is you are still allowing the tire to roll while producing as much maximum force into that braking system as possible, which allows you to maintain control and allows you to stop at a shorter distance. This is something what ABS does. It prevents the brakes from locking up the tire. Okay? And it's totally automated because, again, it's monitoring wheel speed sensors. So if you are in an accident or an accident's occurring in front of you, mash on that brake pedal as hard as you possibly can, right? You're going to lock up those tires, but before it locks up, the computer's going to release the brakes.
Just that little bit so that
Yes.
you lock up.
Right? People think, oh my goodness, that's bad, I want to stop. Correct, but the problem is you're applying too much pressure. Okay, then it engages, then it backs up, then it engages. And it's doing this within milliseconds of each other. So it's basically going da 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 da, right? And it's allowing the tire to keep rolling while it's stopping and
Can
slowing.
you do that again, please?
No. You can watch the replay back on YouTube.
There's no video of it though. It's only
Okay.
sound.
Right?
Hey, yo.
Now, again, besides decreasing stopping distance, when your ABS is being engaged, it still is allowing you to have control of the vehicle. So if I need to swerve out of the way or move, right, this still allows me to do that as I'm driving. Okay? It doesn't just let me lock up and then I'm skidding and going, well, I'm going into that telephone pole, I can't stop it. With ABS, you're able to do that. This is especially important on winter conditions, right? When it's icy out. There's a few years ago I had a phone call from a teacher. Hey, I just pushed on my brake pedal and my pedal was vibrating like crazy. What's wrong? Is my car broken? I go, no. You were on an icy road? Yeah. That was your ABS. It's supposed to do that. That saved your butt. Okay? Kind of fun.
And I still need that truck.
Alright, here's a good illustration of what a wheel speed sensor looks like. It's literally just this little Hall effect sensor. There is no physical connection between the wheel speed, the sensor, and the actual like ring here. Okay, there's a ring that goes around like this.
This is just a motion sensor.
Okay? And there's teeth on there. Don't worry about him.
Right.
There's teeth on this ring. You know how we talked about the crankshaft?
Yeah.
And that reluctor ring would spin with the crankshaft and we had a little sensor and it says, okay, we can know where cylinder 1 is at in TDC. You guys remember that all the way back in like September, October?
Yeah.
Okay? It's the same exact sensor. But instead of monitoring the crankshaft, we're monitoring the spin of the axle of the tire. And we're monitoring that. So the teeth are sending out a pulsation wave back to the computer of volts. okay? High volts, low volts, okay? That is then, it's actually an alternating current, by the way. This is a sensor that generates its own electricity based off of how fast that's spinning. That gets sent to our body control module. That body control module then determines the RPM of that wheel and determines if we need to engage the ABS based off of that. Okay? And again, some vehicles will actually use that same sensor to dictate whether or not your tire is properly inflated. Because again, all of that changes how that tire spins. Fun fact of the day, you don't need to write this down, but let's say I have a vehicle and I want to get new tires on it and I get bigger tires.
Oh.
Right? Because, hey, I'm going to lift up my truck when I get bigger tires. Awesome.
Don't do
Does that affect your ABS system?
Yes.
100% it does, because now all of a sudden the computer is thinking that you have smaller tires. Now you have slower turning on your wheel speed sensor.
And it messes with your speedometer and
It messes with everything.
and your TPMS.
Correct. So you have to understand that, oh, I want to do just this one small thing on my vehicle. It has a lot of different implications on how that affects your vehicle, more than what you can possibly imagine. So don't just go in and start modifying things and hoping that it's going to be the same as it was before. It's not.
One of the trucks at work got new tires, and it's off by like 8 miles an hour.
Yep.
The bad way.
Which means that your ABS system is more likely to be probably engaged, or your TPMS light comes off.
It comes on. Yeah.
ABS channel. There's a separate hydraulic circuit that feeds into each one of your individual four corners of the car, which means your computer system or your ABS can independently apply brakes on either of the sides of the vehicle, which is kind of fun. Okay. Again, 4-channel ABS system is most common nowadays. Each vehicle, each tire is going to have that. Even on pickup trucks, RWAL really isn't the thing anymore, as far as I'm aware. Back in the day, they actually taught you in driver's ed, because we didn't have ABS back in the day. Under slippery conditions, you'd have to pump your brake. You would have to manually engage the brake and then let off. Press the brake, let off. Okay. Guess how many people in a situation where they're panicking are going to be doing that?
No, like 7%.
Yeah, probably a whole lot of nobody. Okay. Because your mental facilities or faculties is not thinking about letting go of your brakes as you're trying to slow down. So ABS has been a huge innovation. Now I can mash that pedal all the way to the floor and hold it, and the ABS system is going to do that for me. It's going to do it better for me than what I can do. All right, literally 2 more slides. Traction control systems. I literally need to accelerate from a standstill as fast as humanly possible. So guess what I'm going to do? Mash down on my throttle. What happens if I have too much horsepower?
You spin.
I'm literally going to be losing traction from my rear tires because they're going to be slipping, right? So yes. So guess what happens? Okay, our ABS system actually engages our brakes to slow the spin of our rear tires as I'm accelerating, so that way I maximize the grip to actually allow me to accelerate faster. Which is weird to think about. We're using our brakes to allow us to accelerate faster. But that's what traction control allows us to do.
Guys, if you turn your traction control button off, then you can spin your tires.
Yeah, then you can spin your tires all you want. Okay? And again, besides reducing engine power, the traction control system, along with obviously the ABS system, is going to allow you to control the vehicle around corners in slippery conditions better. Because again, if I'm making a corner and my rear is starting to slip out, I'm having something called oversteer. Okay, the vehicle's over rotating. I can actually start to engage my rear brake system, right, to allow that to come back into play. Okay, if I have understeer, where the car's not rotating enough, right, I can actually engage my front brakes or a combination of whatever that is in order to rotate the car to get around corners. And this is happening without any driver input. The vehicle is monitoring through these various different yaw sensors and G sensors and wheel speed sensors to say, I'm going around a corner, the driver wants to go around the corner, I'm going to engage brakes, traction control to allow me to do that under most driving conditions. Which again means that you're in your car and you're driving 70 miles an hour, you're going to go around a corner, it allows you to do that, but it's not developing any skill from the driver, right? It's relying on these systems. So now all of a sudden you hop in a vehicle that doesn't have traction control or ABS, and you're going to go around the same corner at 70 miles an hour, you're spinning out, you're crashing.
Wow.
Well, what's going on? I did everything the same thing I did previously. Yeah, but you didn't realize your vehicle that you were driving in previously had all of these systems on board
Okay, but
to
what-
make you a better driver without actually making you a better driver.
What cars don't have those nowadays?
Most vehicles are going to have traction control ABS standard nowadays.
Are you talking about like generation, just in like which generation does not have those?
Like
Past 2000 or something?
probably early 90s, 80s.
Yeah.
Yeah. So it's interesting that I grew up with vehicles that had no ABS or traction control or any of these.
When you were a kid, you used to ride your horse to school, guys.
I used to ride my horse to school. It's crazy.
Yeah.
How did you get to school?
I walked up a hill both ways.
What?
That's